Hello everyone, we're going to cover section 2.3 in this PDF file. Once again, you should have read over 2.3 prior to looking at this video. You should be familiar with the following terms: set operations, that is the union, intersection, complement of sets, understanding the general idea of a Venn diagram and how it is a visual representation of the relationship between several sets. Okay, you should now stop the video, work out the problem, then play the video. I'm going to pause for a second. Okay, so what is a Venn diagram in general? In general, a Venn diagram is simply a visual representation of the relationship between several sets. Let's start off with the universal set, which is this square box. The world is contained within a square box. In this box, all train stations that are in our world exist in this box here. Sets are represented by circles. So we have one set called the red line, and any and every station associated with the red line is contained within that circle. We also have a set called the green line. Any and all stations associated with the green line are contained within this set. We also have one more set, and that is the purple line. Any and all stations associated, well, that's not green. Any and all stations associated with the purple line will be contained in that circle. So, as you can see, when I make a mistake, it just shows up. It's unedited, and hopefully I catch my mistake. Please just let me know. Okay, these videos are live, and again, I don't edit them. So let's move on here. All right, so I'm going to clear this out. So that's the general idea of a Venn diagram. Now, I'll just take note here. So look at this right here. These three characters, these four characters down here, these apparently are stations which are not associated with either one of the red, green, or purple lines. So they can't be inside that circle, but apparently they exist. They just don't exist in the red world, the green world, or the purple world. All right, now let's get back to things here. I'm going to clear this off. Let's start answering questions. Select all trains that do not have a stop at Trento. So they don't stop at Trento, meaning the train lines that do not have a stop at Trento. So here's Trento. So the train lines that do not include Trento consist of only one, the green line, because Trento is in the circle associated with the red line. It's in the circle associated with the purple line, but it is outside of the circle associated with the green line. Second question, how many stations are only along the purple line? So only along the purple line. Well, here's the purple line right here, right? There it is, the purple line. Well, we want only along the purple line. Well, we have to look at only Graz, Anthem, and Warren, because the other ones right here are associated with red and or green, and we want only the purple line, so there are three. Okay, finally, I'm going to clear this out. So again, I'll lose everything apparently, but I'm trying to figure out why. But I'm going to clear this out, and we're going to answer question C. Which stations are along neither the red nor green line nor the purple line? So none of the three lines. They got to be outside of the three circles. Well, there they are. These are the ones outside. So Cadaz, Ponce, Bern, and Hafa. All right, so that's this particular problem. We're going to move on. All right, pause the video, give the problem a try. So we have a Venn diagram associated with sets B and C, and of course the universal set, which again is a box that contains our circles which identify our sets. We want to shade in the set that consists of elements in B or elements not in C. So in B or not in C. Well, remember what union means? If it's in one, throw it in. So we're going to throw in B. So everything in B is going to be thrown in. So I'm going to use yellow for my color. Okay? I'm going to use yellow to color in B. So B or C, not in C, right? So again, union, either one. Well, not C is everything outside of C. So everything outside of C. And everything outside of C consists of, I'm not going to draw this thing in all the way, all right? But that is essentially, we're going to just cover it in. But you have this little piece here only because, again, remember, that is B right here. And as long as we're in B, we're good. Union means either or. Okay? There we go. Next problem. Pause the video. Let's give it a try. Construct a Venn diagram illustrating the following set relationships. We have the universal set, which consists of everything, and we have B and C. Now, here's the suggestion. Work inside outwards. That's not a given, but in general, that's what you try to do. We have 4 different regions here. One region here, a region here, a region here, and a region here. We want to fill in each of those regions, okay? So that's what we're going to do. But the tendency is to work from inside outwards, all right? So maybe I should have marked my regions 1, maybe 2, 3, and 4. But again, you never know. It depends upon whatever information they provide you here. So let's do it here, all right? First off, this region here consists of the elements that are associated with B and C. So it has to be in B and it has to be in C. Well, B and C is empty. There is nothing in the middle here. Okay? Nothing there. They don't have anything in common. So let's fill in B. B consists of the numbers 3, 7, and 9. Now, be careful. Don't put 9, 7, or 3 anywhere in this region right here because that region is supposed to be empty. Because if you put it here, you're saying it's in C. And 3, 7, and 9 are not in C. Likewise, C consists of 1, 2, and 8. Those 3 numbers. Okay? So, am I done? Nope. Because I have to be aware of the universal set. 1's taken care of. 2's taken care of. 3 is. But notice 4 is missing. 4 is outside of those 2 circles. 5 is outside of those 2 circles. 6 is outside of those 2 circles. 7 is in there. 8 is in there, and 9 is in there. So now every element in the universal set is represented, and therefore we are done. Okay, you need to stop the video, work the problem, and then get back with me. All right, Again, we're going to fill in this Venn diagram to illustrate the relationships between these four sets. So the suggestion is you work in the middle. So I'm going to try working with different colors here, so hopefully we can. So here's the bullseye. Whoa, that's pretty colorful, huh? There's the bullseye. That is the set that consists of elements in all three, A, B, and C. So 1 is not, 2 is not, 6 is not, but notice 8 is in all three sets, so we know that right here we have an 8. Now, I'm working outwards. So I personally will now look at, I'm going to lighten up on my color here, this region right here. Okay, that region consists of A and B. These two areas right here, where the 8 is, and up here is A and B. So what do A and B have in common? They don't have a 1, they don't have a 2, they don't have a 6, but they have an 8 in common. But be careful, you're not going to put an 8 up here, okay? Don't put an 8 up there, because 8's already been located. It belongs to C and A and B. So this little region here is actually empty. Now I'm going to move on. I'm going to now consider this region. That consists of elements in A and C. So in A and C. But notice we've already filled out the middle. So anything else we find is going to go in this little tiny area right here. And I'm going to get my black pen working, because I really should have the black pen working. Well, A and C have a 1 in common. They have a 2 in common. And they don't have the 6 in common. But again, they already have the 8 in common, but that's been covered. So 1 and a 2. Moving on. We're going to look at this region now. Okay? That region is B and C. What do B and C have in common? Well, they don't have a 3 in common. They don't have a 4 in common. They do have a 7 in common. That 7 has to go right here. Why? Because it doesn't belong to A. It only belongs to B and C. Remember, we've already figured out what belongs to A, B, and C. It's only 8. So 8's taken care of again. There is a 9 in common, so we got to put a 9 here. So now if you notice, B and C have an 8, 7, and 9 in common. A and C have a 1, 2, and 8 in common. But we also know that 2 and 1 do not belong to B, so we don't have it in the middle. Moving on. Let's look at A. Now for A, we have everything covered except what's out here. So what's in A? The 1, but we already have it. The 2, but we already have it. The 6, we're missing the 6. It has to go up in here. The 8, we already have it. So now we have A taken care of. Let's look at B. B is this circle. Well, for B, we need the 3. It's missing. It's got to be here. The 4, it's missing. It's got to be here. The 7, we already have it. The 8, we already have it. The 9, we already have it. So that's good. We're ready for C, which is going to be this circle. So we got a lot of color going on here, right? Well, let's get back to it. C needs a 1, we have it. A 2, we have it. A 7, we have it. An 8, we have it. A 9, we have it. In other words, this section right here is empty. We already have C covered. Apparently every element in C belongs with another set. Now there's one more that students tend to forget, and that is the universe. We have to make sure every element is covered. Well, we have our 1, we have our 2, our 3, our 4. Do we have the 5? Nope, we're missing 5. Well, guess what? It's got to be on the outside. We got our 6. We got our 7, 8, and 9. So here's our completed Venn diagram. It only took 5 minutes for me to tell you that. All right, we're going to move on now. And this is the last one for this particular section. Stop the video, read about it, and let's get moving. All right, so apparently we are looking at a Venn diagram that is focused on various animals that are being taken care of, okay? And in particular, animals being taken care of by Dr. Hayes, Evans, and Harris. And apparently none of them care to work with mice, quails, or snakes because they're outside those 3 circles. So if you have a snake, I don't know who you're going to take it to. Okay, I did have a quail for a pet, I'll be honest with you, and it was a neat pet. But anyway, that's for another day. So let's select all doctors who treat cats. So if you treat a cat, they're the cats. The cats are in the Dr. Evans circle. The cats are in the Dr. Haynes circle. But the cats are outside of Dr. Harris. What is that guy's problem, huh? Doesn't like cats, apparently. He'll take care of an elk, but not a cat. All right. Well, that's, again, not our issue. Let's look at how many types of animals are treated by Dr. Evan or Dr. Harris or both. So Evans or Harris. So you're either in the Evans world. So there's the Evans world. Well, 1, 2, 3, 4, 5, 6. Or you're in the Harris world. And here's the Harris world. So if you're in either one of those 2 circles, you are being treated by one of these doctors. And it does say both. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I might as well try to be correct here. Because again, Alex rewards you when you get it right. Final question. Which types of animals are treated by all 3 doctors? They're treated by all 3 of them. Well, if you're treated by all 3, you got to be here in the bullseye because these are the only 2 that are in all 3 circles. Everybody apparently likes to treat an elk, and apparently they all like horses. And that ends it for this particular section, 2.3, and I'll see you in 2.4.